Going to be uploaded. The answer keys will still be uploaded, and you'll still be able to watch videos for help. And that's just going to make sure you're good to go for the online assignment. Okay, so here we go with 3-1. Everybody, here we go. So this unit, we're starting with rationals. Now, we're going to be dealing with rational expressions and rational equations. So rationals are, oops, wrong thing's open, no wonder. So we're going to be simplifying rationals, and then we're going to multiply and divide rationals. So rational means it can be written as a fraction, right, everybody? Rational means it can be written as a fraction. So with simplifying rationals, you'll be dividing out exact factors only. So guys, I can't focus right now. I'm can't even think because people are talking. So once again, I have to completely start over because I can't even think. So rational means can be written as a fraction. We're going to be dealing with rationals. With simplifying rationals, you will only divide out exact factors. So I'm going to start out really basic. Just look, this is just getting my point across. What's 27 over 3? We know it's 9, right? But technically, we just know that because it's kind of memorized. Technically, what you're doing is you're splitting up, you're factoring 27. Factors mean what? Multiply to be 27. 9 times 3, correct? So then 3 over 3 divides out to be 1 over 1, correct, everybody? This becomes a 1 and a 1. So 9 times 1 is 9, divided by 1 is just 9. Does everybody understand? So that'll be the same idea with rational expressions. If we have 27x over 3x, we would divide out exact factors. 27 factors to be 9 times 3, and then we have times x, right? And on bottom we have a 3 times x, so we would divide out exact factors. 3's divide out to be 1, x's divide out to be 1. Left is a 9. Does everybody understand? Okay. So now here's one rule of thumb. I always see students, if I don't give this rule of thumb, they mess up and they do some forbidden rules. So one rule of thumb, if it's being multiplied, you can divide it out. If it's being multiplied, you can divide it out. If it has an addition sign or a subtraction sign, you can't divide it unless it's an exact factor. So for example, look right here at this first thing. 2 times x minus 2 over 4. Do you see how 2 is multiplied to x minus 2? You can divide out 2 and 4 because 2 was being multiplied. Do we all understand? Yep. So wouldn't this become 1 over 2? Okay, so that would leave us with 1 times x minus 2 on top. On bottom is a 2. Does everybody understand? So with something like this, they have x minus 2 over 2. People will like to say, oh, those 2's divide out. You can't do that. X minus 2 was a subtraction sign. It was connected. There was no multiplication sign, so you can't just divide those out. Does everybody understand? Now here's why. Isn't x also divided by 2? Okay, if you just divide those out, then that would be breaking the forbidden rule. But if you have something like this, right? X minus 2, you see how we have an x minus 2 on bottom. And it's being multiplied to 2. So those could divide out because those are exact factors. That become 1 over 1, right? Which is 1/2. Does everybody understand when we can and cannot divide? So with something like this, 2 minus z over z. People say, oh, z's can divide out. Wasn't z connected with a minus 2? So you could not divide those out because they're not being multiplied. Does everybody understand? Okay, awesome. Okay, so because rational expressions, last thing, then we'll just practice. Now here's the important thing. Because rational expressions involve a variable, we have to restrict the domain. Because if we have an unknown, that means we can plug anything into it, correct? So we have to restrict the domain. Now here's why. We should know that we can never divide by 0. If we have a fraction, we can never divide by 0. That would make the function undefined. So we're gonna restrict our domain, and domain is input, right? Everybody? Yep. So we're going to restrict what we can put into the polynomial by saying, okay, our bottom cannot equal 0. So looking at this, we have x over x times x minus 2. Couldn't this potentially equal 0 if I plug in 0 into the function? Right? Wouldn't that make a 0? Wouldn't also 2 make the bottom 0? Does everybody understand? So that would be a problem, right? So we would have to say x cannot equal 0 or 2. Otherwise, the function's undefined. Does everybody understand? Okay, now we can simplify it. We have an x on top and an x on bottom. We get 1 over 1. So wouldn't that be 1 over x minus 2? So this is our answer as long as x does not equal 0 or 2. Because if it did equal 0 or 2, our bottom would have been 0 and it would have been undefined. Not this answer, it would have been undefined. Does everybody understand? You have to specify. That's part of the answer. This is our answer as long as x does not equal 0 and x does not equal 2. Because if it did equal 0 or 2, we would have got a 0 in the bottom of our fraction. So the important thing is, this is the original polynomial. We're technically plugging in a bunch of, we can plug in any number into this. We're not, but we could, except the only numbers we couldn't plug in were 0 or 2. You see what? We make the bottom 0. So once again, that's why we had to state those as part of our answer. This is our answer, but x cannot equal 0 or 2. Does everybody understand? Okay. Let's practice. So, number 2. So whenever we're simplifying polynomials, we want it in its most factored form. Because remember, you can only divide out exact factors, what's being multiplied. So a lot of people will say, well, q plus 1 over q squared plus 4q plus 3. Now notice yours has a typo, so fix it. It just says q plus 4q plus 3. It's supposed to be q squared plus 4q plus 3. So a lot of people, if it wasn't in its factored form, then you wouldn't know that there is a q plus 1 down here in the bottom. So we have to factor it, and then we'll restrict our domain and then divide out exact factors. So it's basically, if you didn't factor it, there might be factors in disguise, I call it. You know what I mean? Factors that you don't know are there. Does everybody understand? So let's factor the top. Isn't the top already factored? Okay, so we have a q plus 1 on top. On bottom, it's quadratic, we're factoring it. So we're doing what multiplies to be 3 and adds up to be 4. 1 times 3, isn't it quick factoring? So this is going to factor to be q plus 1 times q plus 3. Now, one of the most common mistakes is people will divide things out before they restrict their domain. We've got to restrict our domain before we divide anything out. So isn't the only problem when the bottom equals 0? So we're looking at when will this bottom equal 0? So q cannot equal 0. If I plug in 0, that's okay, right? 0 plus 1 is 1. Okay, so guys, you set q plus 1 equal to 0. What do we get? Q equals -1. Set that equal to 0. Q cannot equal -3. Okay, we've restricted our domain. So now we can actually divide out exact factors. Q plus 1 on top. Do we have a q plus 1 on bottom? Yes. We're not going to make the tragic mistake of saying our answer is q plus 3. Those didn't just disappear. They became 1s, right? So on top we had a 1. On bottom we had 1 times q plus 3, which is just q plus 3. So this is our answer as long as q does not equal -1 or -3. Because we can plug in any other value for q besides those two values. Does everybody understand? No questions? We're all good? Okay, let's do another one. Number 1, we factor the top, factor the bottom, divide out exact factors. So what's on top here? What's in common? 6. Left would be p minus 6. On bottom we have an 18. Now we'll restrict our domain. Is the bottom ever going to be equal to 0? 18. Isn't the bottom always 18? Okay, so there's no restrictions here. Can't we plug anything into this? Yeah, we won't run into any problems. Okay, sweet. So now we can divide out exact factors. 6 times, so we can divide this 6. That becomes 1 over 3. So our answer is p minus 6 all over 3. There were no restrictions. Questions? Okay, let's do number 3. Okay, we know this is 8b to the 5th over 64b to the 4th. Isn't it all multiplication as it is? So we can start dividing. Actually, we better restrict our domain first. B cannot equal 0. Isn't that just 4 b's on bottom? Guys, factor it. Set each of those equal to 0. So b cannot equal 0. Correct? Does everybody understand? If I plug in 0, will I get a 0 on bottom, guys? Okay, so we know that b cannot equal 0. Otherwise, the bottom would be 0, which is a problem. Top can be 0, but bottom can't. Okay, so now we can divide out exact factors. 8 over 64 becomes 1/8, correct? B to the 5th over B to the 4th is B to the 1st on top, correct? So we have a B on top. On bottom, we have an 8. That's our answer as long as B does not equal 0. Because if we plug in 0, we get undefined when B is equal. Okay, we're all good? Yes. Let's do number 4. So we have an x plus 1 on top. Nothing to do. We don't have to factor that. Let's factor the bottom because there might be factors in disguise. So we're looking for a multiplied to be -1 and adds up to be 0. 1 times -1, correct? We should be really good at factoring. We can quick factor it because our a value is +1. So this factors to be x plus 1 times x minus 1. Divide out factors first because we are plugging it into our original function. So x cannot equal -1, right? Or 1. That's part of our answer. And now we'll divide out exact factors. Those divide out to become 1s, correct? We have a 1 on top. On bottom, we have 1 times x minus 1, which is just x minus 1. There's our answer, as long as x does not equal -1 or 1, because then it's undefined. Awesome? Feeling good? Okay, just a couple more. Number 5, on top, it's not quadratic, so aren't we factoring out greatest common factor? Do they both divide by 14? Yep. Let's pull out a 14. We've got to factor out the greatest common factor, so then left is 3, let's see, 14. What is that? 56 divided by 14. Okay, 4c minus 1. And then on bottom, what's the greatest thing in common? A 6, right? And left is 4c minus 1. Is everybody feeling good? Back to the top, back to the bottom. Now let's figure out when the bottom would equal 0. Is 6 ever going to be equal to 0? Nope, we're good there. But this part could be 0. 4c minus 1. When does it equal 0? Add 1, right? 4c equals 1. Divide by 4. 1/4. So we know that c cannot equal 1/4, or else the bottom would be 0. And now we can divide out exact factors. 14 over 6, don't they both divide by 2? 7/3. Those divide out to be 1, correct? 7 times 1 is 7. 3 times 1 is 3. So our answer is 7/3 for any value except for we can't have c equal to 1/4 because it would be undefined. Questions? We're almost there, then I'm going to let you practice a pinky promise. Last one, then I'll let you just go for it for a while and see how you do. Number 10, looking at the top, what would we do? This one's a good one. Factor out 70, right? Greatest common factor. So then left would be d squared plus 2. On bottom, we factor out 2d. So then left would be 3d minus 1. Is everybody good? Now we would restrict the domain. Careful here. 2d equals 0. Divide by 2. Isn't d cannot equal 0? Okay? And then we get 1/3, right? D cannot equal 0 or 1/3. Does everybody understand why it's 1/3? Okay. Now let's simplify. 7 over 2 doesn't simplify. D over d. D squared plus 2. Now that is quadratic, but it doesn't factor any further, so we're good. So our final answer is 7 times d squared plus 2 on top. On bottom we have 2 times 3d minus 1. There was nothing more that simplified. You don't need to multiply it out. You can just leave your answer in factored form. Does everybody understand? However, if this answer wasn't there and I said 7d squared plus 14 over 6d minus 2, isn't that the same answer? It was multiple choice. If I did distribute, wouldn't it be the same answer, guys? Okay. All right, so do front. You're doing 22 through 27 in class right now, checking those with me. Ready, set, go. You're doing the front, and you're doing 22 through 27 on the front. Pull yourself away. Once again, that's all that's required in class on that part. That's it. Okay, so now we're going to talk about multiplying and dividing rational expressions. When multiplying fractions, don't we multiply straight across? Okay, now there's an easy way and a hard way to do this. So when multiplying fractions, it's easiest to first divide out exact factors, then multiply. Here's why. Everybody look at this example so it'll make sense. 4/5 times 25 over 2. Couldn't we just multiply straight across and say 100 over 10? And then that equals 10. But that was like, you would need a calculator, some of us, right? Okay? Now there was an easier way. Here's why. Before we multiply straight across, let's divide out exact factors. Isn't 4 divided by 2, 2 over 1? Isn't 25 over 5, 5 over 1? Now isn't that much easier? 10 over 1. You see that? So do you see how I took and I divided out factors first and then multiplied straight across? Okay, that's what we're going to do with these. So let's look at number 3 first. Here we go. Guys, too much talking. Here we go. Number 3. So this one will be a requirement for you to do because I'm doing it in class. So what we would do is we'd say we need to divide out exact factors before we multiply straight across. Because aren't we going to have something huge on bottom if we do that? And then factoring is going to be a nightmare, right? So we're going to first divide out exact factors. Now remember, you don't know if you have exact factors unless it's all factors. So this is my suggestion. Put yourself in go off to the side and say, I'm going to designate this only for the factored form of this. And then I'm just going to show my work over here. So I'm going to factor that piece. What do we factor out? 5, and then left is W minus 5, correct? That one's pretty easy. This one, what am I factoring out? A 5, and left is W minus 2. Okay, so this one didn't take a whole lot of work. I'm going to factor that. That's good. Times W. Now factoring this piece. Well, multiplies to be negative 25 and adds up to be 0. 5 times negative 5. I can quick factor it, so doesn't the bottom, this piece, factor to be W minus 5 times W plus 5. Okay, so this is why I do this, is because now it's easy for me to divide out exact factors first. We have a 5 on top. Do we have anything that divides with 5 on bottom? Yep, 5, right? We have a W minus 5 on top and a W minus 5. We have a W on top, nothing on bottom. So what was left on top? 1 times W, which is W, correct? And on bottom, we have W minus 2 times W plus 5. You can leave your answer in factored form. You don't need to distribute. This is the answer. Now, notice in the instructions, it doesn't say you need to restrict the domain, so you don't need to. Does that make sense? It will specify restrict the domain if you need to. Okay, everybody feeling good about that? Okay, let's go back to number 1. Looking at this, we would factor it. Isn't it already factored as far down as it can go? So now we multiply straight across. You might see the answer multiplied out. So let's practice multiplying the top out. That would be 6 minus 3z, correct? Nothing divided out, right? Sorry, I didn't say that. Right? Nothing divides out. Okay, can I divide that z and that z? No, there's a subtraction sign. Okay. So then on bottom we would have 4z plus 5z squared. Now, that one I just multiplied out to make you understand. You could see it either or if it was multiple choice. We all understand. But I want you to just keep it in factored form. Most of the time they'll keep your answer in factored form. Okay, let's do number 4. Here we go. Number 1, I multiplied it out just to show you. You could see it either or. There was nothing more we could do. So we're multiplying these polynomials and then simplifying. Let's divide out common factors first. To do that, we've got to factor it. So what's in common here? 16, right? Wait. Let's factor out the greatest common factor. Okay, yep. Let's factor out a 16, and left is u minus 2, correct? Now that piece we're good, so we have a 2u, and then we're timesing by 3, and then u cubed, and that's factored technically. In common here is an 8, correct? And left is 7u minus 3. Okay, we factored it. Now we'll divide out exact factors only. Careful on this one. We have a 16 on top and an 8 on bottom. Doesn't that become 2 over 1? Oh, but don't we have a 2 over 2 now? We can divide that, right? It's multiplication. So 2 over 2's divide out. We have a u minus 2 on top, nothing on bottom, so we still have a u minus 2. 3 on top, anything on bottom? Nope. U cubed on top and a u on bottom. Yes, right? U, and this will become u squared. Okay, so we've simplified everything we can. On top, there was a u minus 2 left, correct? There was a 3u squared. I'm just going to write that in front. That's just, they tend to write those kind of things in front. And then on bottom, we had a 1 and a 1 and a 7u minus 3, correct? This would be our answer. Okay, number 9.
I have a question.
Yes.
So we start with factors like
Yeah. No, because they're not being divided straight across, right? Because that's division, right? Yes. I just want to ask a really good question. Everybody look, if I have this, u minus 2 over u plus 3 times u minus 2 over u minus 2, let's see, this is a bad example. So I got asked a question, can you divide out this u minus 2 with this u minus 2? They're not being divided, right? But those two could divide. But you never, those aren't divided right there. Does everybody understand that? Okay, awesome. Okay. So number 9, let's quickly do number 9. Everybody look with me. We have this times this. Don't we multiply straight across? Yeah. And this is over 1, correct? Yeah. So we factor this. The easiest way on number 9 is to factor out, what do they all divide by? No. Do they all divide? We want to factor out the greatest thing in common. Okay, let's pull out 6. Left is 2b squared plus 3b minus 14. And now, can we factor that even more? Yes. Well, multiplies to be negative 28 and adds up to be 3. Wouldn't that be 7 times 4? Negative 4, positive 7. Careful, can I quick factor this? No. So we would drop and break. So you'll drop down 2b squared. You drop down negative 14. And then you'll rewrite this. I'm strategically putting negative 4b first. Does everybody understand what I'm doing? And then we have plus 7b. I broke down the middle term. Now it's factoring by grouping. In common here is 2b. You guys, we should be excellent factors by now. b minus 2, correct? In common here is positive 7. Left is b minus 2. So I can factor out b minus 2. And left is 2b plus 7. Now we can't forget, wasn't there a 6? Okay, so now we have that. That was just this piece. So we have that times b over, let's factor this. There's a 4b in common. Does 49 divide by 4? Okay, so let's factor out a b. And left is 4b squared minus 49, correct? Now look. And this is all over 1. Now this piece does factor more. Everybody, seriously, in secondary math 2 honors, I know you learned how to factor, and I know you guys spent a whole time learning, like, if you have 2 perfect squares, do you see how these are 2 perfect squares? The difference of 2 perfect squares, then this is going to be easily factorable by 2b minus 7 times 2b plus 7, right? So, I'm going to rewrite this. We have a 6b minus 2 times 2b plus 7 over 1. Then we're timesing by b over 2b minus 7 times 2b plus 7. And then we can't forget we have a b, correct? We didn't quick factor technically. We could have done it the long way, drop and break, we'd end up here. We used a trick that we should have learned in secondary math 2 honors, where you have a perfect square. I know you learned it, so you can't tell me you didn't. You might have forgot how to do it, but you have 2 perfect squares, right? This is 2b, the front. This is 7. So this is going to factor to be 2b minus 7 times 2b plus 7. So you could have done it the long way and done this times this and adds up to be 0, drop and break, you'd end up here. Okay, so now we can start dividing out exact factors. So look, we have a 6 on top, anything on bottom? No. b minus 2? Nope, gonna cross that out. 2b plus 7 over 2b plus 7, b over v, correct? So on top we had a 6 times b minus 2, I shouldn't have crossed that out. And then on bottom we had a 2b minus 7. Okay, I'm going to give you a second to practice some. So, do front of 3-2, that's what that means. Do front page of 3-2. I'm going to give you a second to start practicing. Listen to my saying. Dividing fractions is easy as pie. You flip the second fraction and then you multiply. So looking at this one, we have this divided by this. It's just 5y plus 7 over 3y plus 19. You flip the second fraction and multiply. So that would be y minus 6. I'm flipping the second, 5y plus 7. And now don't we know how to do those? We divide out exact factors, ding ding, and then we multiply straight across. So y minus 6 over 3y. 3y plus 19 didn't factor. I would have done that. Does everybody understand? Okay, let's do number 15. Dividing fractions easiest by flip the second fraction and multiply. So we'll be multiplying by 8i over 5i minus 6, right? Instead of division. Okay, let's factor this top. Guys, look. This is the difference of two perfect squares, correct? So we can either do this the long way and do 8 times c and then drop and break, or we can know our rule or our tricks from secondary math 2 honors. 5i minus 6, correct, guys? And 5i plus 6. And then on bottom we have a 56i. And now we're multiplying by 8i over 5i minus 6. Now we'll divide out exact factors. So, yes? No, that's just a variable. Good question. So we have a 5i minus 6 and a 5i minus 6 divide out. Uh-oh, careful. 8 and 56 become 1 over 7. That looks like that's all we've got. So left on top, oh, no, I and I, right?
Yep.
Okay, so on top we have a 5i plus 6. And on bottom we have a 7. Okay. So do 14 through 18. Let's just not do 18. I mean, you could. It's not that bad. Well, that's just extra practice. So just don't do 18. So I'm changing my mind. Right now, do 14 through 17. For 2019, a complex fraction is a fraction divided, a fraction on top with a lot of fractions and a lot of fractions on bottom. Fractions divided by fractions. Does everybody see where there's multiple fractions? So how we would take care of this is we would simplify the top. Let's start with 19. Simplify the top, simplify the bottom, then divide. So on top, don't we get a 2? On bottom, we have x over 9. So aren't we now just dividing fractions? So isn't that 2 over, guys, this is where a lot of people algebraically get it wrong. Isn't the top technically 2 over 1? Divided by x over 9. So now we flip the second and multiply, right? So it'd be 9 over x, right? So that's 18 over x. Does everybody understand complex fraction? So let's look at number 20. No? Did I hear someone say no? Okay, number 20. What we're going to do is we want a simple fraction divided by a simple fraction because then we can flip the second and multiply. Right now we can't do that. We've got to fix this to be one fraction. Well, so we need a common denominator. So we'd multiply by b over b, correct? So that would be a plus b on top and all over b because we have a common denominator. So we can put it as one fraction now. Does everybody see what I did? I got a common denominator and then wrote it as one fraction. Now right here we need to multiply by b over b, correct? So let's write it as one fraction instead of 2. So that would be x plus 3b all over b. Now look, dividing fractions is easy as pie. You flip the second one and multiply. So we're doing a plus b over b. We're going to times by b over x plus 3b. Now divide out exact factors only. b over b. That's it. So left was a plus b over x plus 3b. So a complex fraction just means you have to simplify something, and then divide. Does everybody understand?
Yep.
I swear I keep hearing someone say no. Is it you secretly going, no?
It is.
Aren't there like a little goblin over here in the corner like,